Hello everyone, myself Yadagiri, Assistant Professor, Department of EEE, MLR Institute of Technology, Hyderabad. In the last session, we have discussed about the electromotive force production of the single phase transformer, and after that also we have discussed the transformation ratio of the one phase transformer. And based on the requirement, also we have considered the different types of transformer. I mean to say the classifications of the different transformer. So that is based on the number of phases and based on the construction details. We have the three categories. Based on the type of service, also we have the three categories. So based on the type of cooling, also we have the three categories. So these many things we have discussed in the last session. So in this session, we are going to discuss about the numericals based on the electromotive force equation of the single phase transformer. Now let us discuss about the different numericals based on the electromotive force equation of the single phase transformer. So for that, the first question is the question number 1 is so given like the maximum flux density in the core of 250 of 250/300 volts, 50 hertz single phase transformer is 1.2 webers. I mean it is a maximum flux density value as mentioned in the transformer as a 1.2 weber per meter square. If the EMF per turn value is mentioned as a 8 volts, then we based on this data we need to determine the primary and the secondary number of turns, that is N2 and N1 number of turns we need to find. Then after that net cross sectional area of the core we need to determine. So for every numerical, so for every theoretical kind of numerical, need to go with we need to write with the given data. And we need to do the problem with the help of given data. So that's what I need to write the given data. It is a given data we need to consider. So in the given data, so what they have given, the transformation ratio of the transformer given. So that is what E1 upon E2 ratio will given as, that is a 250 upon 300. That is a E1 is a 250, then E2 is a 300, they have given. And the flux density value also mentioned, that is a B max, maximum flux density. So would like to deliver as a 1.2 Weber per meter square. Then also the EMF per turn value. Then EMF per turn. So EMF per turn also given as 8 volts. So EMF per turn also given as 8 volts. Then supply frequency also mentioned like F equal to 50 hertz. So based on the given data, need to find the, so there is a primary and the secondary number of turns. So primary and the secondary number of turns. So first one we need to find the question number 1, that is a primary and secondary number of turns. So first one is a primary, so number of turns, primary number of turns. So how we are able to get the electromotive force on primary means, that is a E1. We already aware about this. E1 is a primary production of induced EMF on the primary winding, that is E1 equal to the, so it is a EMF per turn. So just now, in the last session we have discussed that is the EMF per turn, then into number of turns on the particular side, that is the primary side. EMF per turn into number of turns on the particular side of the transformer. So then we will get the overall EMF of the transformer winding on primary or based on the requirement or secondary also. So for that E1 equal to, need to get the EMF equation on the primary winding. So for that we need to take the number of turns, that is the N1 we have considered. So then after that need to take the whole EMF value for the primary side. Then we need to take the EMF per turn value also. So based on that En1 into, then EMF per turn value is mentioned like so this one. So this is the 8. Then E1 equal to, then N1 into 8. Both same only. So means need to find from this one N1 value. So that is what N1 equal to, then E1 upon 8. Therefore N1 equal to, E1 value how much mentioned according to the question. So this is a 250 upon 8. So 250 given as E1 means if we want to write in terms of so E1 and E2, then we can write it also like that. That is E1 equal to so and so, then so E2 equal to 300. So like this also we can write. So then based on the simplification of this one, we would like to get it as N1 equal to, so I have the answer because so based on the ratio of these two, we will get this answer as 32 turns. So the number of turns on the primary is 32. This is the 1A actually. Only primary we have done till now. Then also the secondary as well. So the secondary is the same, similar to this. Also we can use other method. So what other method? According to the transformation ratio of transformer, that is E2 upon E1 equal to then N2 upon N1. So based on this one, N2 equal to then, so E2 upon E1 into N1. So after this, then need to substitute the values of the E2 and E1. So E2 is a 300 divided by 250. So into 32 we got. So both are gets cancelled. Then this is a 5. Then this is a 6. Then so after multiplication of these two, I mean after simplification of these two, so we will get this N2 as 375. 375. So the primary number of turns on the primary winding is a 32, and the secondary number of turns is a 375. This is the end of the first question. Then next discuss about the question number 2. So question number 2, what they have asked, that is a net cross sectional area of the core. Net cross sectional area of the core. So net cross sectional area means, so we need to take the net cross sectional area of the transformer core means. So we know that in the last session we have discussed the Bmax value. So that is a pi max into then A, I mean pi max upon A. So this is the ratio of the flux per unit area is nothing but flux to density Bmax. So we know that, what we know that, we know that the electromotive force equation of the, so single phase transformer, either the primary or secondary. So need to consider this secondary side, that is a E2 equal to the, so 4.44 into then phi max into then F into N2. So instead of the pi max, what we need to substitute, phi max equal to, so both are need to do the some term multiplication from this one, pi max equal to the, we want to substitute, so B max into A we need to substitute. So this we need to substitute in this formula. Then you will, instead of pi max we will get the expression is going to be like this, A into then F into N2. This is into here also into. So from this one what we want to get, that is asked about the A. I mean I think so the net cross sectional area of the core, yes, that is only. So that A equal to, so it is a E2 upon 4.44 into then B max into then F into N2. So this is what the form, this is what the formula. So then A value, after substituting these all values, so what is the E value is a 3000 or 300, given like, yeah, it's 300, not 3000, it's a 300. So E is a 300, so divide by then 4.44 into then B max given as according to the question, B max given as that is a 1.2 Weber per meter square. Then 1.2 into 50 into 1.2 into 50 into the N2 we have got it as 375, I think so. So 375, yeah, same only. So then after simplifying this one, the net cross sectional area of the core should be, that is 0.03 meter square. So this is what the net cross sectional area of the core. So this is the end of the whole first question. Then next one, problem number 2 need to discuss, that is a second problem. So a single phase transformer has 400 primary and 1000 secondary turns are there. So the net cross sectional area of the core is given as 60 centimeter square, and then if the primary winding is connected to a 58 and 520 volt supply, need to find the what value, that is a peak value of the flux density in the core, and also the voltage and voltage induced in the secondary winding of transformer, that is a E2 or V2 we need to find. So for this also need to go with the given data. So that is a given data. Given data what given? So primary number of turns, I think so, yeah, it is a 400. Then number of turns on secondary also 1000 they have given, and the net cross sectional area of the core is also given as A equal to, that is a 60 centimeter square. So which means 60 into 10 power minus 4 we got in terms of the meter square. So 10 power minus 4 we got based on this one. Then frequency of the supply given as 50 hertz. Then applied voltage, that is a V1. So if it is a what the ideal transformer, the applied voltage should be 520 volts. Then what they have asked to get, I think so, peak flux value of the core, I think. So the question number 1 is a peak flux density. B max they have asked. So B max equal to the pi max into pi max upon A. So this is asked. This question, this one is asking in the question number 1. So here both are, I think so. This was unknown only. So this pi max we will get from the electromotive force equation of the transformer on primary side. So we know that. So the production of EMF on the primary winding should be, that is a 4.44 into then, so pi max into then F into N1. So based on this one, need to find the pi max value. Pi max equal to the then E1 upon 4.44 into then F into N1. So need to substitute all the values. E1 how much given? This is the E1. So according to this, we will like to substitute as a 520 divided by 4.44 into then 50 into N1 is a I think N1 is a 400. So after the simplification of this one, so pi max equal to, we got it as pi max value, we got it as I think pi max value, is it the pi max only? Yeah, pi max only. So pi max value we got like so instead of this one, we directly go through this B max formula. Based on that, we will get, so asked about direct B max now. So from this one, need to get the B max value. So no need to get again this from this one. B max equal to the, asked about what question? Yeah, B max only. So yeah, B max equal to pi max equal to B max into A need to get. Then instead of the pi max, we need to substitute B max into A. Yeah, that is E1 equal to 4.44 into then B max into A into F into N1. So from this one directly we will get B max value. It is easy thing. So this is also the same procedure. We also get the answer again to this procedure, but this directly we will get from this one. So for that 520 again keep as this upon 4.44 into then 50 into 4.44 into then 50 into the age of the core is given as a 60 into 10 power minus 4 into then 400. So from this also we will get that, but based on this we will get the pi max, and after that we need to substitute in this formula. So it is it will take some time. So based on this method, based on this technique, we will directly get the B max value as mentioned in the first question, that is B max equal to the, so that is what 0.976 Weber per meter square. After simplification of this entire thing, so we will get the B max value should be this one. So this is the first question, end of the first question. Next we need to discuss about the, calculate about the question number 2. The question number 2 asked about the induced EMF on secondary side, that is the secondary, so induced EMF. Secondary induced EMF. So that is what the second question. How we are able to get the induced EMF means, so from the transformation ratio of transformer, so that is a E2 upon E1 equal to then N2 upon N1 equal to K. So from the K also we will get, and from this ratio also we will get same thing only. So because we have already done about the E1, so that's what. So from the K we need to get from the K, that is E2 upon E1 equal to K, means E2 value how much they have given. So E2 only we need to find. So based on the ratio of the number of turns, we will get the K. Based on that, we will get the E2 value. First of all, the N2 value. So N2 is the 1000. I think 1000 it is mentioned in the question as that 1000. Yes. So 1000 upon 400. So it is a 2.5 ratio we will get as a K. It is a K. So we know that E2 equal to K times of E1. So from every term we will get K only. That is E2 upon E2, E1 also will get K. Then N2 upon N1 also will get K. So therefore E2 equal to the K is a 2.5 then into 520. So then based on this one, we will get the E2 as 1300 volts. So this also E2, and also other method we can use this one, E2 by E1 equal to then N2 by N1. Therefore E2 equal to, so how much the N2 value? It is a 1000 divided by 400 into E1. How much? E1 is at 520. So after simplification of this one, so we will get the E2 also should be same, that is a 1300 volts. So this is what, so EMF production happen on secondary winding. So that is the end of the entire second question. So next we need to discuss about the question number 3. So it is also similar to the same question almost. So because they have mentioned the 500 tons on primaries, 200 tons on secondary, and the cross-sectional area of the core is given, and need to connect the, so this one. So I'm directly explaining this one without getting any delay. So almost same only. So similar, I mean similar problem, not same. It's a similar problem. So N1 given as 500, then N2 given as 1000. Sorry, 1200. Then net cross-sectional area is given as it is a 80 centimeter square. So which means 80 into 10 power minus 4 meter square. Then primary voltage is a V1 and E1 equal to 500 given. So need to find again flux density. So there is a B max equal to, so we have used the formula is of that is E1. If it is a primary side, then E1 upon then 4.44 into E1 upon 4.44 into then F into N1 into then A. So substitute these all values, 500 divided by 4.44 into then 50 into N1 is the again 500 it is, so into A is a 80 into 10 power minus 4. So this 500 and this 500 gets cancelled. Finally the B max, question number 1 it is B max values, then the B max equal to, so I have the answer with me. So based on the simplification, so it is a 5.63 Weber per meter square. So this is the end of the first question, similar to the last question only, formulas are using, so similar to the last question, that's what. So then the second question asked about the voltage and the secondary only. So question number 2 means, so E2 upon, I mean regard to the transformation ratio of the transformer, E2 upon E2, E1 equal to then N2 upon N1. So we need to get from this one is a E2 equal to then N2 upon N1 into E1. So the N2 value is mentioned as a 1200, I think, yeah. So divide by 500, so into 500. So both gets cancelled then. So the number of tons on, sorry, the production of EMF on the secondary winding should be, is a 1200 volts. So this is the end of the second question. So this is the end of the session. So till now we have discussed about the problem based on the electromotive force equation. So these problems are going to get in the examination. So also important. So based on that we have covered the different numericals in the EMF equation of the transformer. So this is the end of the session. The next session we are going to discuss about the equivalent circuit diagram of the transformer and as well as the losses in that single phase transformer. So thank you and all. Thanks for watching the session.